Hi guys, welcome back. So in this video we are going to create a Faucet smart contract and a front-end application. So we are going to create something like this. You can see it's Energy Web Volta testnet Faucet. Here you paste your address and you request one Volta token. We are not going to implement this like Google Capisha functionality. We are just going to implement this functionality where we are going to input our address and then we are going to request the token. So basically let's go to our project. So if you have seen my previous video of how we can create an ERC20 smart contract, we are going to do exactly the same thing. And so let's first define our two smart contracts. The first smart contract is myToken.sol, and second is Faucet.sol. So in the in myToken.sol, basically it's the same contract, so I'm just going to copy and paste what I have created before. So if you see this, I'm going to explain it a bit. You can see my previous video too on how I created these functions and what all these functions exactly do, but here we are actually focusing on these two things. First is this initializer, where we are going to mint the token, and instead of minting the token to the owner of this smart contract or who deployed the smart contract, we are minting the token to this contract address. So this my token address of this, it's going to return the address of this my token contract, and all these tokens will be minted to this contract address, and we are minting 1 million tokens, and it's 10 power decimals. We are going to give decimals like 18s, just like Ethereum. And this is the function mint, which is going to assign the total supply to the amount we provide in the initialize function, and it's going to add the balance amount to this contract address. So basically we are passing the contract address in the mint function, and it's taking this account, this address, and it's assigning the balances of this account to the total amount or the total token we want to define in this smart contract. And the second thing is, the main thing is the transfer function, because this Faucet smart contract is going to inherit all the function of this my token, and then it's going to transfer. So if you go here, when you are pasting the address, let's say any address, and you request one Volta token, it goes to this my token, and it calls this transfer function. So this is the address of the contract, this is your address which you have pasted there, and this is the amount, 1 Volta token. So it first checks that the addresses are not 0, and then underscore balance of address, it reduces the contract total amount of token, and it increases the amount of token for the recipient, and finally the total supply is decreased to minus amount. And we can also mint the tokens. For example, if let's say the tokens are finished in the contract, and we can again mint the tokens against the address of this account, and it can only be called by only owner, like it's only owner modifier. Only owner of this contract who has deployed this contract can call this function. And this is the transfer ownership, where we are transferring the ownership of this contract to the person who is deploying this contract. So this is basically main token contract. So let's start writing the Faucet contract. And first of all, we are going to import /mytoken.sol, and then we are going to import this OpenZipline enable library. So let's do this, and then we are going to define contract Faucet is enable. We are using this library to define the owner of the contract and transfer ownership, and we are inheriting my token. Now if you go to this my token, this is IERC20 type of token, so we are going to define IERC20 public underscore token. This will be the token address, and unsigned int 256 private amount. This is the amount. If you go here in this application, the amount here is 1 volta token, so we are going to define the amount in our constructor. So we can just we are going to define the constructor later, and then we are going to define a mapping of address So what is this last drive time? Actually it defines if you have got the token, let's say 1 volta token from this faucet, then you have to wait for 5 minutes again. So we are going to define an integer private constant underscore drip interval is equals to 5 minutes. So we are going to define this time so that in order to make another request, the user has to wait for 5 minutes. And then we are going to define some modifier token set. We are going to see if the token address has been set or not. So address of underscore token is not is equals to address of 0, and we are going to give this information as error token address not set and underscore, and then we are going to have another modifier where we are going to see amount set, and where we are going to see amount is greater than 0, because we cannot send 0 token from this contract to some address. So instead of amount, we are going to say it's underscore amount. So this amount set is 0, and then we can also create, first of all we can create our so we can create our constructor here, and in the constructor we are going to give IERC20 token address and unsigned int 256 amount, the amount we want to define for this faucet contract. We can say underscore token is equals to token underscore amount is equals to amount into 10 power 18. So basically this is decimal. You can define decimals here. So we can say this decimal, and finally enable dot transfer ownership to message dot sender, like who is going to call this contract, underscore undeclared decimal. So let's see in our token contract. Let's make it public, and let's see if we can access this in our contract. So now these are the decimals which we are going to define in this token contract, and we are going to create this amount, because if you write something like 2 tokens, it's going to send you 0.000000 something of 2. So we want to multiply this 2 tokens into 10 power 18, because in Ethereum it's something like this. So we are defining 18 decimal places for the coins. So this amount will be assigned here, and finally we want to create another modifier, can drip. It's going to take address of recipient, and it's going to require some condition which we are going to write later after writing the function. So okay, so let's first create a function set amount unsigned int 256 amount public only owner can run this function, and we can say first of all we are going to assign the amount in the constructor, but later if you change your mind and if you want to change the amount for this Faucet token, we can simply say amount is equals to amount into 10 power 18, 10 power decimals. We are going to define the decimals as 18, so that's why I'm saying it's 18. And then we are going to create a function drip. It's actually going to transfer the tokens to the recipient address, and it's public, and we want to see if the token is set, we want to see if amount is set, and we can see if it can drip and recipient address. So these are the modifiers which we have defined before, and then we are going to say call the transfer function of this token address. Like this is the token address and this is the transfer function. So if you go to my token and if you go, so it's going to call this function, this transfer function, and this transfer, and there are two inputs to this function, recipient and amount, and we are going to say last drip time of recipient is equals to block dot timestamp. So basically what is this? As the user has requested a token, we are going to say that the last time a user has got the token, so this is the block dot timestamp, like the current time. And now here in this modifier we are going to use this variable, this block dot timestamp last drip time recipient, to see if the user has taken the token in the last 5 minutes. Before that we need to implement two more functions, which are function get last drip time and address of recipient, and the function is public view returns unsigned int 256, and it's going to return last drip time of recipient. And finally there is a final function drip check. Okay, before writing this function, let's go to the modifier here and let's run this, let's try to write this modifier here. So in the modifier we are going to check if this last drip time and the current block timestamp, if they are greater than 5 minutes, because we need to wait for 5 minutes. So we are going to say get last drip time of recipient, and we are going to say plus underscore drip interval this 5 minutes. So this current time plus 5 minutes if they are less than equal to block dot timestamp. So it means that the 5 minutes are passed. So if they are not, we can say recipient has to wait for 5 minutes. So this is the modifier, and again we can copy the exact same thing and we can go to the function can drip. No, it's like in the function drip check. We are going to use this function in our front end to see if the user has already taken the tokens in the last 5 minutes, and public view returns, it's going to return bool, either a user is allowed to take the tokens or not at the current time interval. We are going to say if this return true. If the 5 minutes are passed, return true, else return false. So if you see, this contract is inheriting from my token, and we are assigning the token address, which is ERC20, the total amount which we want to transfer in each request, and this is the ownership. And then we have different modifiers. If they can drip, if the token is set, if amount is set, then we can set amount, then we can transfer the tokens from contract address to the recipient. And we can check the last drip time when the user has made the last request, and finally we can check if the user is allowed to make a request in the next 5 minutes or not. So our contracts are ready, so we can do is npx hardhat compile. So this is just a warning, so let's just forget it. And here for the scripts, I'm just going to delete it, and we can create deploy.js, and we need another script, deploy-faucet.js. So in the deploy.js, I'm just going to copy and paste this script here, and in deploy faucet.js, I'm going to copy and paste this script. So basically, let's first deploy npx hardhat run -- network volta scripts deploy.js. So we are first deploying the my token contract. We are deploying it. Let's wait for it. Okay, so our contract is deployed, and we can go and copy and paste this address as volta here token, and we have not yet deployed the Faucet smart contract, so we can again deploy this contract too. So let's deploy Faucet smart contract, but if you go to Faucet, in the constructor you need two parameters, this token address which we have just deployed and the amount. So if you go to Faucet, we have this token address, like here the token address is this, and this is the amount which we want to drip. So if you go here in the Faucet, it's going to assign the amount like 2 into 10 power 18. So we need to write just 2 here. So let's do this, and it's going to multiply all those parameters by itself. So we can define 2. So let's say the amount is 2. So this is the token address and this is the amount. If you go here in this application, the amount is 1, but here we are putting the amount 2. And we can do the same thing, and we can say deploy faucet.js, compiled one contract. Let's wait for it to be deployed. Okay, so this is the contract address, so let's copy and paste it here. And so now our contracts are ready. First of all, this my token, we need to initialize this contract here in the, because these parameters are not yet initialized. So let's create a file index.js, and I'm going to copy and paste the code. So it's the same code. You are importing ether library, the environment variable values, the API URL, private key, and this is the ABI of token, and this is provider, signer, contract, and we are defining decimals as 18 because we want to make 18 decimal places for each coin. And then we are going to run this function as initialize. So if you see contract.initialize, so if you go to this initialize function, you need name, symbols, decimals. So we can just go here, we have this name my token, the symbol is mtk, and the decimal places are 18, or we can say decimals. we are going to wait for initialize transaction, and then we can say contract is initialized. In the meantime, we can also see we can see the total supply of the, okay, so we can do something like this. So we can see the total supply of this contract and then the balance of contract. So this is the previous contract address which I have tested before making the video. So we are going to copy and paste this, and we are going to copy and paste this here. We are going to see this is the contract address. So we just want to make sure that if the tokens are minted, against this address, this contract address. So let's say node index.js. Yeah, so you see the total supply of coins are 1 million, and 1 million tokens are assigned to this contract address. So now our contract has this functionality, and what we can do now is let's create a simple function. Let's remove everything. We are going to write this function later, but just for the time being, I'm just going to define a function. Let's define this function main and say this main. We cannot run this initialize function again, but I am just keeping it here just for your reference, and I'm going to upload this code on GitHub. But in the main function, we are actually going to transfer some tokens. No, not in this main. We are going to see the balances, and we are going to mint some tokens against the contract address again, just to test these functionalities, this mint. But right now, before everything, we need to create a front end. So here I'm going to create index.html, and I'm going to create main.js, which is the JavaScript file to interact with the HTML file. And finally, I'm going to create a backend app.js. So this backend server, it's actually just going to serve this HTML file. It's simple, like it's creating an express application, and it's defining the static path, and it's saying that if slash or slash index.html, it should serve this index.html, which we are going to write here. And in this index.html, I'm just going to copy and paste everything here. Basically, this is the styling. This part I hate the most because I don't really understand, or I don't like this styling. But yeah, I just copied and pasted it from online just to make my web page looks better. And this is the simple body. We have this faucet, we have this input field, your address. We are going to take an input of text, that what is the address where we want to send, and this paragraph is the status, and finally there is a button which is going to call this drip function. So if we start our app, node app.js, and if we go here, localhost 3000, so basically this is our front end. So here we are going to put our address, and then we are going to request token, and here our status will be updated. So what we can do now is we can try writing the function here. So I'm just going to copy and paste some stuff which is actually similar for everything, and then we are going to write the contract. So this ABI, I'm going to remove it, and I'm going to paste the ABI of this faucet contract. So contract faucet, and I'm going to copy this ABI from here, and I'm going to paste it here. So this ABI is finished. Now this is the API URL of the blockchain Volta testnet. This is the private key which I have defined here, and now this is the faucet smart contract address. So if I just go, I can copy and paste the faucet address here, and this is the provider, signer, and contract. So this is the contract instance of faucet smart contract which we have created. So let's write drip function. So in this drip function, first of all we have this address which we are going to say document dot get element by id address. So if you go to index.html, this is the address id and this is the input field. So first of all we are going to import it in our code, and then we are going to say a variable can document dot, you can name anything in your code. So document dot get element by id status, so we are going to update the status, and finally we can say status is equals to await contract dot drip check address dot value. So whatever we put in this address, so whatever we put here, it's going to take the value from inside this text box and it's going to use this to check this function. So basically let's go here and it's going to check drip check if this address is allowed to get the tokens. If this address has not yet get the token in the last 5 minutes, then it's going to say true, otherwise it returns false. So we are going to see if it's true or false, and then we are going to say if status is equals to true, we are going to say can.inner.html is equals to please wait transferring tokens, const transaction is equals to await contract.drip. We are going to call the drip function, which is going to call the transfer function, and the tokens will be transferred to this address, and then we can say await tx.wait, and once this transaction is written, we are going to say tokens transferred, else we are going to say can.inner html is equals to you already got tokens in last 5 minutes, please wait. So our main.js is almost ready. We have this contract address and we have this index.html, and our contracts are deployed. So let's start this server again and let's try to do something. Yeah, okay, so I'm going to go here. So this is our front end and let's inspect it too. Let's see in the console if we are getting some error. I'm going to open this MetaMask, and yeah, so let's say this is the account where I want to send the tokens, so I'm going to send it. I'm requesting drip is not defined. Okay, let's go here. Where is our code? In the main.js we have defined the drip function as async. If we go to index.html, we have actually defined drip function. We are importing main.js, okay, where it's giving the error uncaught reference, drip is not defined. Okay, let's see what's going on. Okay, we have our index.html, we are importing main.js, and we have this function on click drip, and const drip is equals to async. Okay, and drip check drip. Okay, we have this drift function here, index.html. Let's do something like this, async function drip. Okay, so now it's working. Please wait, transferring tokens, and tokens transferred. So one way to see if the tokens are transferred are if we go here and we are connected to Volta testnet and we have uploaded our contract to Volta testnet, right? So if we go to asset, how can I remove this? If I come on, yeah, so if you go here, we can actually import tokens, and we need to give the token address. So if we go here, this is the token address I can give, and the token is symbol is mtk, and this is the token. So we can add custom token and we can import token. So you see we have this 2 mtk here, and we can actually see this too in our let's write this in index.js file, and actually I'm going to copy and paste it from my main function. So we can see the total supply, const the balance, and the balance of. So I can just copy and paste these things here. So this is the total supply, it must be reduced, and the balance of contract. So this is the contract address, and this is this, and the contract address, the address of the receiver, was this 0x2bb. So we can actually go and copy and paste it here, and we can go copy and paste it here. So let's run node index.js. Yeah, so you see we had like we had these tokens here. The total supply was 1 million, and the balance of this token address was 1 million. But now since we transferred the token using the Volta using the Faucet, not the Volta Faucet application like Volta Faucet, so now we can see the total supply is decreased and the balance is also decreased. So yeah, so that was all about the Faucet contract. So thank you very much for watching. Take care. Bye bye.